Question 5 is coming from also kinematics, but here we are using variable acceleration. So here we don't use the other three equations of motion. V is equal to u plus at, s is equal to ut plus a half at squared, and v squared is equal to u squared plus 2as. Here we use the expressions given. We tackle this using differentiation and integration. So they're saying the particle moves in a straight line starting from a point O. The velocity v meters per second of a particle t seconds after leaving O is given by this for t ranging from 0 to 4. You may assume that the velocity of the particle is positive for t less than a half, is 0 at t is equal to a half, and is negative for t greater than 1 over 2. That means somewhere they will tell us to find a distance. Here is even part A. Find the distance traveled between 0 and a half. Now, we know that velocity is the rate of change of displacement. So we say v is equal to ds dt. So that means for us to get s from here, we shall integrate v with respect to t. Okay? So now we shall integrate from actually 0 when t is 0 to t a half. To a half. And then the expression for v is t cubed minus 9 over 2, then t squared plus 1 with respect to t. Then when we integrate this, remember, you remove the integral sign. Now, increase the power by 1, you divide by the new power. This will be t power 4 over 4. Then minus, this will be 3 here. When we increase that power, so 9, then t cubed over 2, then times 3. So this 3 here goes here 3 times. So we shall have 3 over 2. Okay? So if we get 3 over 2 as the final here, then this one will be t power 3. Okay? Then plus, of course, 1 is the same as t power 0. So when you increase the power by 1 and you divide by the new power, you get your t there. Okay? So we shall just write t here, and then a half, and then 0. Then we put the limits. So we put a half here, a half, then power 4, divide by the 4, minus 3 over 2, then a half power 3, then plus a half. Then after that, put a minus, go to the lower limit. Of course, everywhere there is t, so that will be a 0. Okay? Now, here, what do we get? I can just put everything in the calculator and I get the answer. A half is 0.5, so 0.5 power 4. Then we divide by 4, then minus 1.5 into 0.5 power 3, then plus 0.5. This one gives us 21 out of 64. So I will just write it as 21 out of 64. You can even write it as a decimal, 0.328125 meters. As simple as that. Part B, find a positive value of t at which the acceleration is 0. Hence, find the total distance traveled between t is equal to 0 and at this instant. Acceleration is the rate of change of velocity. So we shall put acceleration is equal to dv dt. That means we are going to differentiate the expression for v. Remember, v was given as t cubed minus 9 over 2 t squared plus 1. So our acceleration is going to be the derivative of this one. That will be 3. Drop the power, reduce it by 1. Then this 2, when you drop it here, it will cancel with that 2. You remain with a 9 here. Okay? And then t. Of course, when you differentiate a constant, that one disappears. Then from here, we shall equate it to 0 because they said when acceleration is what? 0. So 3t is actually common here. Then we shall have t minus 3, which is equal to 0. So meaning t is equal to 0 or t is equal to 3. That is when acceleration is 0. Okay? Now, since for t greater than a half, the velocity is negative, this means that the area of the region is negative because it is below the t-axis. Okay? Let's go and check back what they said. This is what they said here, that you may assume that the velocity of the particle is positive for t less than a half. It is 0 at t is equal to a half and is negative for t greater than a half. You see this one? So remember, our one value of t we have gotten for acceleration equal to 0 is 3. So if it is 3, then that region is below the t-axis. You see that? So we shall have the total distance. Remember, it is the area under the graph. So actually, let me write this statement here that I just said. That since for t greater than a half, velocity is negative. Okay, this means that the area of the region is going to be negative. Okay, why is it negative? Because it is below the t-axis. It's like you have drawn something, and then this one at a half it was this, then below from 0 to this one, below a half it was positive, then here it is down. So this is velocity time graph, you see? So it is below the t-axis. By the time t is 3, it is this way down. So that's what we are meaning. An area cannot be a negative. So distance cannot be a negative, in other words, because if they said, they didn't say displacement, but they said what? Distance. And distance is a scalar quantity. So first of all, like I've just had this one here. I have something like this, maybe, whatever. This is a half. So we know the distance traveled here. From 0 to a half, we have calculated it before, 21 out of 64. Okay? Then there is this one up to when t is 3. So this one, we add it. But remember, it is going to come out as a negative. So if you just add them together, then it is going to give you a wrong answer. You see that? So you have to be careful. What you need to do, this part that is below the t-axis, you put it in the modular signs. So what comes out as a negative turns to a positive, right? So we shall say total distance is equal to, the first one was 21 over 64, then plus. Now I'll put modular signs. We are integrating from now a half, because remember this one was moving from 0 to a half. You remember? Now from a half to 3, this one we have gotten. Then we integrate, this is t cubed minus 9 over 2 t squared plus 1 dt. Okay, like that. Do you remember that we integrated this one long time ago? Okay, so I'll just pick it from here. It is t power 4 over 4 minus 3 over 2 t cubed, then plus t. So we have here 21 over 64, then plus the modulus of, now when you are integrating, remember you take away the integral sign. So t power 4 out of 4 minus 3 over 2, then t to the power of 3, and then plus t. Now let's put our limits. So we have here 21 out of 64, then plus the modulus. I put 3 power 4, that is 81 over 4, minus 3 cubed is 27, then minus, times that 3. That one will also give us 81 now over 2, then plus 3. Okay, then minus. Now when you put a half in here, we saw already that it gives us the 21 over 64, so you don't have to waste time. This is 21 over 64, like that. So here we have 21 out of 64, then plus the modulus. What is the whole of this together? 81 out of 4, then minus 81 out of 2, then plus 3, then minus 21 out of 64. This one gives us negative 1125, negative 1125 out of 64. So do you see that this one gives us a negative? That's the region which is below the t-axis. So just make this one positive. The modular signs make it positive. So we shall have 21 out of 64, then plus 1125 out of 64. 1125 plus 21. That one gives us 1146, then divide by 64. That is 573 out of 32. 573 out of 32. You can leave it exact or even in decimals. 17.90625 meters. That is that.